Taekwondo is a martial art originating from Korea. Warriors that eventually unified Korea developed the foundations of Taekwondo, an art that has since grown internationally and is now a Summer Olympic sport. Taekwondo makes heavy use of foot techniques such as kicks. The mechanics of Taekwondo are based in simple laws of physics. Note that with the speeds and masses involved, relativistic effects are negligible. A unique characteristic of Taekwondo is the snapping technique. Useful in both punches and kicks, strikes are performed with a snapping motion, so as to minimize time and contact with the target and thus maximize impact. All strikes seek to have the greatest impact on its target, or exert it on it the greatest force. Therefore, the momentum of a strike just before it collides with its target is the source of its power. Power is work over time, more force, more work, more power, thus more force, more power. While two strikes may have the same momentum, the time and contact will make a difference with respect to the force applied on the target. By snapping back right after the blow is dealt, one avoids wasting momentum and absorbing impact, thus maximizing the damage imparted. A roundhouse kick works much the same. A snap is imperative to maximizing force. The roundhouse kick is a staple of Taekwondo. It makes use of circular motion to deliver a powerful strike. Assuming the kicker exerts the same centripetal force throughout the strike, the fastest moving part of the leg is the foot, being the outermost end. The roundhouse kick is delivered along the instep up to the toes, which are pointed throughout the strike. The radius of the striking area from the center of rotation is the largest along the leg. Therefore, it is moving the fastest. More speed means a greater momentum and thus a greater impact. The power behind a strike is rooted in its dynamics. Newton's second law plays another large part in the power behind a strike. Force is directly proportional to mass, for example. If one kicks solely with the weight of their leg and not their whole body, then the kick will have lesser force on its target. This simply demonstrates the proportionality of force and mass. As a strike is performed, sufficient time is needed to accelerate the strike so as to maximize momentum upon collision. For a punch, this is demonstrated by the difference between a jab and a full punch delivered from the hip. The arm exerts a constant force to accelerate itself and thus the fist toward the target. The final speed of the punch is dependent on how long it accelerates, starting at rest. Therefore, increasing the distance traveled by the strike before it meets its target increases time while maintaining acceleration, thus increasing momentum upon impact. A running flying side kick is a somewhat larger scale example of this principle. The farther the kicker runs prior to the kick, the greater momentum he or she has. By jumping just before impact, the kicker maintains its horizontal velocity and thus momentum. To some degree, a combination of horizontal momentum and vertical momentum due to gravity increases the overall impact. An axe kick is performed by lifting one's foot as high as possible before bringing it back down in the direction of gravity. Examine the axe kick as a good way to demonstrate conservation of energy. Kicker uses kinetic energy to reach a certain height and therefore gain gravitational potential energy. This potential energy returns again to kinetic energy as the foot drops back down onto the target. A way a strike's power may be demonstrated is through breaking, in which a board is broken using a strike. While momentum and good impact is important, when breaking, one must take into account the pressure of one strike. For example, a palm strike may have the same power as a punch, but the area of effect is spread out across the palm. Since pressure is inversely proportional to area, minimizing the area of effect increases pressure. Therefore, a punch that uses two knuckles has a greater pressure on the board than a palm strike that uses one's palm. Beyond strikes, self-defense is an important part of Taekwondo. Joint locks typically manipulate an attacker by gaining leverage over a sensitive joint like the wrist, shoulder, or elbow. Leverage is another way of saying torque. In a joint lock, it's typically advantageous to grab at points that maximize a force's radius from a pivot point, the joint. The closer one gets to the pivot point, the harder it gets to have the same leverage. This is because in order to have the same torque, one has to compensate for a lower radius with a greater force. Taekwondo uses fundamental Newtonian mechanics to maximize the power of one's techniques.